everybody, and welcome to our webinar series on software protection and monetization. My name is Holger Schulze. I'm Director of Marketing here at SafeNet, and I'll be your moderator today. Thank you for joining today's webcast on how to protect Java-based software products. Because of its platform independence, Java has become increasingly popular with software vendors. Yet Java's open source code, publicly available .class file format, and its simple instruction set leave it open to prying eyes and hostile analysis. So as organizations move their software products to Java, their critical intellectual property can become more vulnerable to reverse engineering, manipulation, and theft. So our webcast today will examine the nature of those Java code vulnerabilities and the limitations of existing solutions, and also how comprehensive enveloping of the Java code, which combines both obfuscation and encryption, can be an ideal solution for protecting critical algorithms and other intellectual property of your software products. Our presenter today is Dale Hopkinson. Dale is a sales engineer here at SafeNet, and he has many years of experience in the software licensing and protection industry. And I'm looking forward to this presentation. But before we get started, I'd like to remind you that you can submit questions at any time during the live webcast. Simply click the Ask a Question button on your screen. We will collect all questions during the webcast and have a detailed Q&A session at the end. Also, if you would like to share this webcast with your friends and colleagues, please click the Share This button on your screen now and share the webcast link using Twitter, LinkedIn, or Facebook. Now, without further ado, let's get started and open the line for Dale Hopkinson. Dale, take it away.
Good afternoon. Thanks, Holger. So as Holger mentioned, it's a very high-level presentation, as we always do today, kind of to touch upon Java, the popularity of Java, some unique things. As you all know, most people on the line, they're using Java or closely knowledgeable about Java. Some of the most popular things, of course, are vulnerabilities, and the ways you can protect your solution against piracy. So as we see from this slide, we know that Java applications are really increasing in popularity. Most ISVs have embraced Java to some degree. Really, for the most significant advantage of really the program language Java has is platform independency. As you all know, it can run almost on any architecture or operating system, rather than having to bind an application to a particular hardware architecture such as Intel or PowerPC, which makes it very nice, for a lot of developers. But the same thing that gives it that, that layer of ease of use or ease of programmability is also increase of vulnerability. So with the ability with Java sort of be write once and run anywhere, it's really a tremendous advantage. But there's also a very real risk of developers losing possibly their IP. And probably I would say three of the highest reasons that Java is very vulnerable to a lot of attacks during runtime is, first of all, the JVM is open source. As you all know, Sun has made the source code freely available for JVM, which makes it simple for hackers. It's free and it's readily available, so they have the same access as you do. So the hackers can simply look at the code to see exactly how the virtual machine works. Really also, as Holger had mentioned with the Java .class file, the format as well is publicly available. As mentioned earlier, Java source code is compiled into bytecode, which you all know, which is stored in a .class file. The specs of the Java .class file format is publicly available, once again making it easy for a hacker and even someone with or without a technical background to either write a tool to process, modify, or transform the .class. Or you can even search on Google for free tools that does this already for you. A lot of newbie hackers don't even need to have the knowledge. They simply have the internet connection, and they can go on Google and find a freeware tool and possibly do some damage to your unprotected software. I would say one of the main three reasons that really Java also highly vulnerable to reverse engineering. The JVM is not software, is software, not hardware. Pretty much unlike standard programming languages that require expert understanding of the specific processor, the JVM is an application that acts like a microprocessor and uses built-in capabilities provided by the OS and computer hardware. So really, because hackers don't have to step down to the hardware level, it's easier to gain full control over that over the JVM. And just an example of that, when debugging standard native development languages, pausing the processor is something that's very extremely difficult, and that would require expert knowledge of the processor for debugging capabilities. But of course, since the JVM JVM is open source and software, that makes it very easy to do. I think we just advanced one too many slides there. There we are. So as well, and kind of on a side, we just briefly touched upon third-party disassemblers. That also increased the risk. JVM is, as I mentioned, inherently vulnerable to reverse engineering, both commercial and freeware disassemblers. So really, the software, other than the out-of-the-box approaches you have, so there's many onboard measures I wouldn't go in today of you can protect with Java. That Sun offers many onboard out-of-the-box things. But some additional things you can do to protect your application, of course. Really two ways when you're looking at software security. You have some sort of file wrapping, which we mentioned is our envelope. It's very fascinating to implement. You get robust protection. And one of the nice things for developers is no source code is touched here. And and later on we'll share some unique things we're doing with our envelope utility, how you can do method level protection, you can, decrypt and encrypt individual classes and so forth. And then of course you also have the API, ability to use API protection. So with the envelope you do not touch any source code. It's pretty much you just wrap your J2E or jar file. With the API, of course, you have the access to source code, so you can do unique checks, checksums. You can read and write to memory, encrypt, decrypt. You have the ability to control the calls and also the output, so you can catch and control error messages. So with the API, you do get that granular protection, and you can even decide to take the API and implement with your back office systems and such things. And you can also do a higher level of reporting. So just initially, looking at, as I mentioned, our envelope, the SafeNet Sentinel HASP envelope. What it does, it just gives you, easy IP protection, copy protection, anti-reversing, debugging protection. Let's see, and it's easy. It's just easy to implement. I'm going to just advance the slide here to kind of show the envelope in action, and then step back into it. So the envelope, once you protect your application with the envelope, you see you simply lock it to a key, whether it's a hardware key or software key. And at runtime, you can decrypt the application or parts of the application, maybe possibly a function or a class that's needed to run a particular functionality. And once that piece is tied to a particular license on the key, which is secured by the license on the license key logic, it runs according to that license on the key. Whether it's a trialware application, like say try before you die, or the full version that supports either the module-based, rental-based, or floating-based license. So pretty much you can just lock it to any kind of license or any key type. And here's I just want to kind of step back into the envelope. So unique for the envelope, what we're doing with the Java protection, it can allow you to protect your J2E files and deploy them as, with the Tomcat 6.x web server. I know that's something a lot of people have been asking about. It's very popular. With Java as well, we base off encryption, AES 128-bit encryption. But we can allow you to do also, of course, a symbol obfuscation and even code obfuscation. You can drill down and do so on the method level. So, of course, as the method with the Java method is just a series of statements that perform some repeated task. You can actually drill down and say, I want to protect an individual method or methods. So you have that ability to define different methods. And once you do that, you can actually decrypt, encrypt and decrypt those methods with a different subset of AES keys. So the benefit you get of that is every method or methods you decide to protect individually, they're going to bear a different encryption, which just increases the security. Again, one of the nice things as well, you can have any kind of external class loaders are now supported as well. As if you do any kind of Java reflection API, previously that was something that was not supported, but if you have any kind of, third-party Java API reflection in your own application, you can use that without any problems with the envelope. So that just gives you the additional functionality and ability to increase your chances of securing your application. So once again, a Sentinel HASP envelope is just an automatic file wrapper that provides a robust protection against the software reversing. Again, the nice thing is you're not touching any source code. So after you build your Java application, you simply go ahead and protect that and decrypts the class files when it's requested at runtime rather than just loading all the class files in a virtual machine at once, which just really prevents a hacker from rebuilding the entire application. Move on to the next slide here. And of course, we do also offer the API protection. So the API is just what you can take and plug it into your own source code, embed security calls into your own codes. So then you have the ability to either catch and control the error messages. You can of course do unique things. So when you use the envelope, it pretty much you can either say, I'm going to check the key and decrypt either when the entire application is loaded, or you can say, when I call a particular method. Those are really the two options you have. You can do a background check, but of course with the API, you do get that granular level. You can do random function calls, which of course thwarts hackers. You can say, I want to do something at a certain frequency, read and write to memory. You have those additional checks, the additional functionality to do such things like checksums. You can just verify the file integrity. Then as I mentioned before, you can also take the same API and you can tie it into any kind of back office systems, whether it's you want to integrate to your ERP, CRM system, for reporting and things like that. We have customers who've tied it in some of their Java web applications, to do automatic updates, ping a finance system once a credit card is available and valid. Once it's charged, send an update down to the customer side. So you can take the API and implement it as complex as you'd like to, or you can even take the API and implement it very basically by just doing a login, logout call, which login just says that the key is there and it's available, the license is there. Once you're done, you log out. And of course, if you did want to use both envelope and API, you can. You just, of course, implement the API level first, since, of course, when the envelope is not going to touch the source code, you're going to simply wrap any kind of coding you've already done. So just briefly, support we offer for any other kind of languages. With the runtime API, you can see the list there. There's also a few that are not up here, Fox Pro and some of the other languages that people ask for. But if there's a language that you're not seeing, do you have any questions if we support it or not, you can feel free to send an email in to our support team. They'll be happy to assist you with that. And of course, we just briefly mentioned on the protection side, how is protection being done? So again, you can protect two ways, either the envelope or the API. But that's only half of the equation. Once you protect, you must have your locking type for the licensing. Now again, your locking type, Sentinel HASP, allows you to now take your protected entity, and you can either use one or even both of the locking methods. You can have a hardware key or a software key. And if you can mix and match with different customers, and the true beauty of the solution is it does not require you to change the application or call the engineering resources again to alter that binary. You simply produce licenses on the fly to either meet your customer and or business needs. And then one last slide before I turn it back over to Holger today. So on the top here is where we kind of focus today, again, on a very brief and high level. Focus more so on protection, just to show some unique things we're doing for Java. But one of the next upcoming webcasts, we're going to focus on licensing to show you how you'll take that protected application with your locking type and then license it. So again, once you protect your application, it's only half the equation. You now must choose a locking type and license that application. So with that said, we'll just turn it back over to Holger.
Thanks, Dale. All right, so before we start the Q&A, let me give you a very brief overview of